Uh, and the first thing we're going to do is we're going to take a draw a picture. So it's a parallelogram A, B, C, D. So draw yourself a nice little parallelogram. Label it A, B, C, and D. Draw yourself your diagonals. And it says the diagonals intersect at point E, so label this point E here in the center. So you've got your picture. First thing to do is take a look at this. What am I asked to prove? Maybe don't highlight it on your picture, but I will. So you can see what we're looking at. So we have AED, so we're just trying to prove that this triangle is congruent to the one across from it. And so there is so many different ways you could decide to prove these triangles congruent. I will go without staying away from just using all three sides to prove this. But keep in mind, you can almost use any triangle. You can use SAS, you can use OAS, and you can even use ASA. But I'm going to do side. Do two columns. You have statements on the left. Given information was just the fact that they told us A, B, C, D is a parallelogram. Usually what you want to do is if they gave you the fact that it's a parallelogram, when you can write the recent definition of a parallelogram and write what that means. And what that means is that you have opposite sides that are parallel. Unfortunately, I don't really want to prove the angles in this case because I'm using side. So I don't have to write that. I'm just going to go straight to the fact that AD must be congruent to BC. So that's the left side and the right side of the parallel. And that is true because one of the properties of parallelograms is that opposite sides are curved. So the reason you like that because you have any curves that you have parallelogram. So at this point, any of the properties that are true, you can write as a reason those opposite sides are good. So I'm just going to go ahead and mark my picture. So I've got that broken down right there, the left and the right. And another very important property of parallelograms is that the diagonals bisect each other, which means that the E is technically the midpoint of both of those segments. Now, I don't need to say anything about midpoint because the property says the diagonals bisect each other, which is enough to show that we have two segments that are equal. So in this case, we have DE, which is this bottom part, must be congruent to EB, must be congruent to EB. And then we're going to do exactly the same thing, but for the other diagonal. So the other diagonal will be AB congruent to BC. So right now we have that one. Then we're going to do AE is congruent to EC. And that is the same reason. The diagonals bisect. So I'll go over here. So we see now, as you see, all the three sides of these triangles are marked. AE, so then we can basically just write the answer. So whatever the previous one was, AED is congruent to CED, and the reason is these side are congruent. So just to show you another way you may have to do this, as you can use these two steps that show those two sides equal to each other, and then maybe you want to go down further. So you want to use AED to get over the here. You could put equal AED is congruent to C. Because they're vertical angles. And then what you would have there is you would have SAS instead. So you put SAS in here at the bottom. But there's so many different ways you can use side. Easier ones. You can also use alternate interior angles. So you have an angle here. You have an angle here that have angles that look at interiors. Same thing with this angle. This angle here, they have alternate interiors. So the properties of parallelograms give you a lot of information. So this is just one way to disprove